All right. So, can you guys hear me? All right, so today we're going to go over a couple of Leetcode easy questions. As you can see, I've already done most of them, so let's just get into it. These are usually just for warm-up, so there are some interviews where they'll give me maybe 3, 4, or 5 Leetcode easy questions in the span of around a 45-minute interview. So these are definitely questions that you can actually get asked, and they expect you to answer them pretty quickly. And they ask multiple of them within the same round. And also sometimes they just give you these questions as kind of a warm up to a more difficult question later on in the same 45-minute interview. So recently I took an interview and they asked me around 4 or 5 of these in the span of around 45 minutes. And they also asked me an easy Leetcode easy question right before a Leetcode medium question. So that's just an example. So this one says remove duplicates from a sorted array. So obviously you're going to have sorted array from input, and you already know from the title it's going to be duplicates. So that's the thing about easy questions. Easy questions, basically the whole problem is within the first title that you read. That isn't really the case later on in harder questions. You're going to have to actually understand all of this stuff that they give you in order to actually get the question right. But for easy questions, you should be able to understand what the problem and the input is based off of the title and maybe a little bit of reading. So this is given a sorted array of num. So you have sorted array, remove the duplicates in place. So that's really important to remember. You can't forget that. Such as that an element appear only once, and return the new length. Okay, do not allocate extra space for any other another array. You must do this by modifying the input array in place with O1 extra memory. All right, so this is also important too. You have the O1 extra memory, which means that you can't create memory such that the amount of memory that you use scales with the size of the input. So you can't do that. You have to have, you can create as much memory as you want, space as you want. You just have to make sure that it's always constant no matter what the size of the input is. All right, so given num is equal to this sample array, your function should return length is equal to 2, with the first 2 elements of nuns being 1 and 2 respectively. It doesn't matter what you leave beyond the returned length. Okay, so what it's saying is that this should be 1 and then this should be 2, and you can actually leave whatever is there. You can leave it there. So that should be fine as well. Okay. It says given num is equal to this, your function should return length 5 because there are 5 unique numbers. So 0, 1, 2, 3, and 4. So the first 4 or the first 5 indices should be 0, 1, 2, 3, 4, and then the rest, it doesn't really matter what it is, and you return the length of the array, or the length is always equal to the number of unique elements inside of the sorted array. So that's fine. Okay. It says clarification, confused why the return value is an integer but your answer is an array. Okay, so that's obviously because it's going to be in place. So they need whatever programming language you use, whether it's Python, C++, Java, there needs to be some sort of reference to it. So yeah, in C++, you just use a pointer, or you pass it in with the ampersand. Okay, but we're going to do this in Python just because I feel like Python is the easiest language to use when it comes to interviews. Most interviewers allow you to use Python, and I have been asked before to switch from Python to Java or C++, just to see if I could do it, but most of the time they let you use Python. So if you want to cast the widest net, that's also a really efficient language to use when it comes to writing things like this. I would use Python. C++, everyone is going to accept C++ too, but the thing is, it's not as fast, it's not easy, it's hard to remember the library names and everything. So I just find it easy to use Python. So yeah, basically you're given the input array. So nums in this case is the list. And it's saying basically that this is all going to turn into a return of an integer, which is going to be the size. So let's say I'm given, for example, 1, 2, 3, 3, 4, 4, 4, Now the length of this sort of array, I should be returning 1, 2, 3, 4, right? So 4, the length should be 4. And then the array or the nums list that they passed in should be 1, 2, 3, 4, and then I don't really care what I have after that. Basically like that. Like or if I wanted to, I could have 2s here, right? It basically doesn't really care what comes after this. So that's pretty easy. Since I know that this is in array that is already sorted, that's another key. It's already sorted, so what I can do is I can say, okay, if there are duplicates, then I want to get rid of the duplicate. However, if there aren't duplicates, then just leave it in place or put it in the next available spot. So in this case, we have 1. It's not a duplicate because this is the first item, so we don't even have a chance to see duplicates yet. Then we have 2, also not a duplicate. 3, okay, we assume it's not a duplicate because we just came from a non-duplicate, so this couldn't have been a duplicate. And we couldn't have seen 3 somewhere earlier than that because this is sorted. So obviously, if we had already seen a 3 before, it would have been immediately to the left of this 3, but it's not there. Okay, so now we say, okay, we've seen 3. Now we get to this 3. Oh, we've already seen 3, and we're going to need to figure out how to determine whether or not we've already seen a number. In this case, you can just maybe keep a variable that says this is the number that I'm currently on, and until I switch to a new number like 4, I'm just going to say just keep going, and also keep maybe an integer that says this is the index that I'm currently at, where you should insert newly seen numbers. So what we can do here is we can say, okay, I know I need an integer for current index or next available. I'm just going to call it next available. You see what happened there? Next kind of got highlighted. So never call something next because there are reserved keywords that, and it can cause a lot of confusion later on. So I'm going to call it next available. So I'm going to set that equal to 0 because 0 is the first index available to put our newly seen number into. And so I wanted to keep it next available, and I wanted to say cur. So that's the current number that we're seeing right now. So for example, over here, we're going to switch this to 3. And when it gets here, we're going to say, oh, current seen is 3, but we're seeing a new 3 right now. That means we shouldn't include it. We shouldn't put it into the next available slot. But then when we get here, current seen is going to be 3 still. And now we're going to see 4 though. And we're going to say, okay, maybe we can say last seen. So that makes more sense. So when we're here, we're saying last seen was 3. Okay, whatever. We don't want to include it. Here we're saying, okay, current is 4, but the last seen was 3. So we do want to include it in the next available slot. So we're going to put it in the next available slot, and then we're going to increase this next available by 1 to shift it over by 1. All right, so let me show you what's going to happen here. So we're going to have 1, 2, 3. Okay, now we're at the point where we're here. We're going to say, okay, we're at 3. We're going to look for the next available slot only if this current 3 is not what was last seen. Last seen is going to be at this point 3, and we've already seen it, so we're not going to add it to the, we're not going to move it. So we're at 4 now, and we're going to assume that last seen is at this point 3. This current seen is not equal to the last seen, so we do want to include it into the next available slot. So the next available slot is right here. We're going to put 4 in. Then we're going to move on to this 4. We're going to say, oh, last seen. Oh, when we move on from this 4, we're going to set last seen equal to this 4. Then for these 2, we're going to say, oh, they are equal to the last seen, so we're not even going to do anything with them. And at the end of the day, it doesn't matter what we do with this excess size. It's not going to be checked as the problem stated above. Okay, so we should definitely include something called cur index. Okay. So next available and cur index are refer to positions inside of the array, and last seen doesn't refer to a position, it refers to the actual number that was last seen. Okay, so now I think I can just iterate through the num. So for I in range, so yeah, I created a for loop that basically is going to iterate through the nums and this in this case should be the length of the nums. So for I in range, length of nums, so I is an index inside of nums that starts at 0. Okay. I could change this to cur index. So yeah, for every index inside of nums. Okay, so the first thing, the original state is everything is going to be set to 0. Last seen is going to be set to 0. Last seen shouldn't be set to 0. That's not accurate, because let's set last seen to nums at 0. So let's set last seen equal to the very first number inside of the nums. Let me just get rid of this. This is just our example to work off of. So last seen is going to be set to the nums at 0. And we know that this number is always going to be included inside of the end result. So let's just put it inside the end result. And we're going to say, we're going to iterate from starting at index 1, which means don't include the very first number. Only iterate through these items, the rest of the items. Okay, so we're going to iterate through the rest of the items. And we're going to say, okay, last, okay, so so at this point, we want to iterate through the list and say if the current index, if the item at the current index is equal to the one last seen, don't do anything. So nums, so the way we represent that is nums at current index, if that's equal to last seen, and the first time this iterates, we're going to be looking at 2. And if it is equal to last seen, oh wait, we should also make current index 1. We want to start inserting here. Anyway, so if it is equal to last seen, then do nothing. However, if it's not equal to the last seen, which is in this case, it is not equal to the last seen, we want to update last seen to whatever we're seeing right now, which is this, in this case 2. Then we're going to put what we're seeing right now into whatever is at the next available index. So now the list, which is called nums, at the next available index is going to be, in this case we can just use last seen, but I don't want to because that is ugly. We can just say, all right, we can just set it equal to the num at the current index. So essentially what we're doing, in this case we're just putting 2 into itself. But for example, over here at 4, we would be putting 4 into this location right here later on. Now obviously when we do this, we need to update the next available slots. Okay. And again, if it is equal to last seen, if nums at current index is equal to last seen, then we don't really want to do anything. And at the end of the day, we're going to also want to keep a counter. So starting at 1, because we already inserted 1 at the very beginning. And this counter is going to be incremented every single time we see a unique element. So that's also what we're going to return. All right. Let's see if it works. Oh, in Python, it's yeah, hashtag to get a comment going. Okay, so let's see if it works on this basic test case. So my answer was 2, 1, and the expected answer is 1, 2. So there was obviously some error where I put 2 inside of this right here, and let's check. So let's see here. Length counter is equal to 1. Next available. Oh, okay. So next available started at 0 when it should have been at 1. Current index is equal to 1. Length counter. We actually don't need to define current index here. Length of the counter. Yeah, it does start at 1 because we already put 1 inside the very beginning. Does that make sense? So that looks like it works. Obviously, that is not enough of a test. You need to put more tests. So this is testing a little bit more complex example. Yeah, that looks like it's working. Now some interviewers are not going to do this, but many are. They're going to do things like give you empty arrays, and they're going to say, oh, what about this edge case? So my answer, okay, well, the expected answer is the runtime error, so I'm assuming they're not going to give you that. But let's say we need to test another test case, which is an edge case with one item by itself. So at this point, I'm okay with the confidence. Okay, they did give me that test case. That's just theirs had a runtime error, so I don't even know why they gave me the test case. I think theirs has a runtime error, but yeah. So if length of nums is less than 1, it's probably going to return 0. I'm actually sure what they want in this case, but I'm just going to assume it's 0. Okay, so that was accepted. So let's look into the details. So it says the runtime beats 76.8% of Python 3 submissions, and let's look at the memory usage. My memory usage beats 99.18% of Python 3 submissions. So this is good in terms of memory, and we can see here that the way that other people did it is they did some sort of remove duplicates thing. This person did. They kind of popped and put okay. Yeah. While pop, so that's probably why their memory is so high. They're not taking advantage of the fact that you can just leave this stuff here. Don't worry about it. It's sorted. That's probably why they have such a high amount of memory access. Okay, so let me go back to problems, or probably explore. I forgot what it is. Shoot, or was I mock? Nope. I don't really like the UI for this Leetcode site. Okay. So I just did this one again. I guess we can just do this one. Say you have an array for which the ith element is the price of a given stock on day I. Okay, so you have a list of elements and every single day is represented by I. Design an algorithm to find the maximum profit. You may complete as many transactions as you like. For example, buy one, sell one share of stock multiple times. Okay, you may not engage in multiple transactions at the same time. You must sell the stock before you buy again. So it gives you an example. It says, so this is a probably going to be like something like a greedy problem. I'm not sure. So the design algorithm to find the max profit. So on day 2, buy on day 2 for where prices equal to 1, and sell on day 3 where prices equal to 5. So you make a profit of 5 minus 1 is equal to 4. Buy on day 4, prices equal to 3, 4, and sell on day 5. So where price is equal to 6, and then the profit is equal to 3. And then you add up the profits. Okay. So yeah, this is an example of a very easy greedy problem. Greedy solution just means at every point in time, try to make the best decision with the information that you have in the most greedy manner. So I'm assuming it's just like this. Whenever you see a price that's lower than what you originally paid for, don't sell it. But if you do see something that's higher than what you originally paid for, then do sell it. And if you see, if you buy something and you see something at a lower price before you see it at a higher price, then just imagine that you bought it at that lower price. All right, so for example, starting at 7, okay, imagine when you buy at 7, and now you see a 1. Well, 1 is less than 7, so let's just, from here on out, imagine that we had bought it at 1. And now we see 5. Well, might as well sell it, so now you have 4 profit. And now you don't have anything, right? So you move on. So you could also imagine that if you didn't sell it, then you might as well have sold it, because in order for it to be something worthwhile, you would have seen something at a higher price. So for example, what if it was 7, 1, 5, which would cause you to sell it, and then like 100? Can you buy and sell it the same day? No, right? Because let me see the you must buy one, sell one, share the stock. You may not engage in multiple transactions at the same time. You must sell the stock before you buy it again. Yeah, I'm not sure if this means that you can't buy it on the same day that you sell. So if I were to sell here, I would make a profit of 4, and then if this was like 100 right here, you would be able to buy it on that same day. Well, then I guess your profit. No, okay. So yeah, this is pretty much the simple greedy solution. So buy price. Let's assume I bought it on the first day, so actually, I'm just gonna say. So yeah, for every price inside of the current prices, or every current price inside of the length of the list of prices, if the current price is greater than the buy price, and obviously I'm going to keep a running total of the profit. Let me start with 0 profit. So yeah, I'm going to add on to the profit the current price minus the price I bought it for. So if the current price is actually less than the price that I supposedly bought it for, then I'm going to assume that I bought it for that lower price. So the way this is going to work is current price is going to be starting at 1. So for every current price inside of prices, it's actually going to go over 7 again. That's fine. If the current price is greater than or equal to buy price, do something else. Just put 7 into current price or into buy price, which was already there in the first place, so that's fine. Now let's go to 1. Buy price is now equal to 1. Now let's go to 5. Current price is finally greater than buy price, so I'm going to add onto profit current price minus buy price. So that's going to add on to profit the number 4. Now I'm here. Buy price was 1. But I don't have any stock right now, so I need to factor that in. So I'm assuming I have stock true. So yeah, if I see this, okay, actually. Oh, I forgot to return the profit. Now let's go see that test case I was talking about, because they didn't really specify that, so this could be completely wrong. Oh, okay, so if you do have, for example, one right here, go right here, you have this 100, you could have made $99 based off of this 1 to 100. Okay. That's interesting. This is actually a little bit more difficult than I thought it would be. So this actually, I did it completely wrong because I didn't understand the question. Let me think. I mean, I've already solved this problem before, so just have to think. Oh, I think you can just do the greedy solution where you just keep buying. So keep going until you see the highest price locally price, then sell it there, then buy again, then just keep going until you see the highest local price. I think that should work. So let me see. I'm going to set the highest local price equal to 0. I'm going to set profit equal to 0. What do you call it? For price and prices. Okay. So if the current price is greater than the highest local price, so for example, if I'm here, then I have the highest local price. Okay, let's say the highest local price is set at 7. We're now at 1. If the price is greater than the highest local, which is not, then okay. So yeah, price is greater than the highest local price, which in this case, you start at 7, then you go to 1, and it wouldn't be higher than the local price. You go to 5, it would be higher than the local price, which is 1. You probably want to sell it, or you want to keep going until there's a higher price that you could be selling it for. So let's say we're at here. The current price is less than the highest local price, but you bought it at the highest local price, right? So you bought it at that price, and it's also the highest local price. But you still always want to do profit minus bought price. Okay, now the reason we want to do this is because at first it's going to execute to adding $0 to the profit, because the highest local minus bought price is going to be 7 minus 7. So we're at 1, for example, and we're going to say, okay, the current price is 1, which is less than the highest local price, which is 7. However, in this case, we want to add the profit, which is just 7 minus 7, onto the variable profit, just because it'll be useful later on, even though right now it doesn't really affect the profit. But now let's assume that we're in this case 5. Okay. In this case, we can't buy if we just sold on this day. So we have to remember that. So we have to keep track of whether or not we bought. So we're going to set it equal to true because we're holding the very first element inside of prices stock. We're always going to buy on day 1, essentially. Okay, let's get rid of this else statement for right now. Let's just focus on this. If the price is in prices, if for prices in prices, if the price is less than the highest local price, in this case 1 is less than 7, then do highest local price minus bought price. Bought price was equal to highest local price. You're going to add a 0. Next. Now, what are we going to do with 1? Well, if we did this, bought price minus highest local price, or highest local, then what we're just going to do is say, okay, now buy me. Buy the stock that I'm at right now, which is actually, yeah. So I'm going to say the bought price is going to equal to the current price, which now is equal to 1. And then we're going to move on. Okay, now we're at 5. Price is not less than the highest. Oh, okay, so highest local is also going to equal bought price. So that's fine. So So the highest local is equals to the bot's price. Now, what happens if price is not less than the highest local? So, for example, 5 is not less than the 1. Then we don't want to do anything, because what if later on you see 100, right? And now price, so in this case, okay. If this doesn't execute, then that means that the highest, so that means the current price is actually greater than the highest local price. So we're going to update highest local price with the current price. So in this case, for example, 5 is going to be, so when we're iterating on this index or for price is equal to 5, okay, so right now the highest local is 1. So 5 is not less than 1. So we're going to set the highest local price equal to 5. And now we're going to go to 3. 3 is less than the highest local price. Okay. But the bought price stayed the same. So we're going to do 5 minus 1, which is 4. And we're going to put that inside of profit. Then we're going to buy the current one that we're at, which is 3. And then we're going to set the highest local price equal to this 3, because that's the highest we've seen so far. Next, we're going to go to 6. 6 is not less than the highest local, which is 3. Highest local is 3. So we're going to set the highest local equal to 6. Then we're going to be at 4. At 4, 4 is less than the highest local price, which is 6. Right? So we're going to add that profit. So 6 minus 3 here. Then bought price is equal to current, which is 4. And then the highest local is equal to bought price. Okay? And if it weren't, then we would go with that. Okay, now this is great, but it leaves out a corner case. What happens if this was a 7 here? What if instead it went 6 and then 7? So imagine that this was 7. Then we would go to this else statement and say highest local is equal to price. And then we wouldn't ever do the actual transaction of highest local minus bought price. Right? So at the very end, we have to check if highest local is greater than bought price profit plus equals bought price. And then also we want to update it in the case that it goes okay, so if it's trying to take a step down, for example, high price is less than the local highest, let's see, doesn't return the why does it return 1? Profit plus equals highest local okay. In this specific example, it just happened to be that this last one, which I got wrong right here, which I messed up on, ended up making up most of the test case. So in this case, the price just keeps going up, and it should at the very last one do 5 minus 1 and go to 4. And then the final test case, which is this one, it's always going down. So it's always in this, so price is less than the highest local. It's always just doing 7 minus 7, 6 minus 6, 4 minus 4, 3 minus 3, 1 minus 1, and it always just adds 0. So that looks like it's right, but of course, Leetcode does this thing where they give you empty arrays. So if oh, right. If the length is 1, then you can't ever sell. This is a bit better than half of Leetcoders. Okay. Honestly, that was pretty bad, just because in a real life scenario, that would have definitely been a failed interview, just because I didn't understand the question at first. And in real life, I would have been able to ask an interview to clarify. I would have probably gone over that example that I talked about with the 100 after the 7 before I started coming with the algorithm, because the interviewer would definitely be able to answer a question like that. And that's one of the downsides to Leetcode. You don't get a practice asking an interviewer questions. In Leetcode, they always have to make sure that the information that they present to you is enough information for you to be able to answer the question. But in real life interviews, a lot of the time they're going to ask you questions and purposely leave out some details, because they want you to understand that you need to ask about those details. So the simple fact that in real life, you're not always going to have all the details right in front of your face, that alone seems to be a skill they're testing for. So you need to be able to figure out what information you need in order to answer the question correctly before you start coming up with a solution. So I'm kind of bored of arrays. Strings, everyone knows strings. How about let's go with linked lists. So write a function to delete a node except the tail in a singly linked list given only access to that node. So given a linked list's head to this linked list, which looks like the following, it gives me the node. Okay, so it gives me the node value, not the index, and it says delete the node with that value. Right, so that seems pretty reasonable. So it says the linked list will have at least 2 elements. Things like this, all these nodes, you should be asking your interviewer for that. They're not going to tell you that. They might give you like 1 or 2 of these, but you should definitely ask more about test cases and what happens if this happens. Just think about the problem before you even start coming up with the solution, because they definitely a lot of times purposely don't tell you all the information you need. So anyway, the linked list will have at least 2 elements. All of the nodes' values will be unique. So that would have been a good question to ask, right? What happens if you have duplicates? Which one do you delete? They're going to tell you, okay, all of them are unique. The given node will not be the tail, and it will always be a valid node of the linked list. Do not return anything from your function. You just want to delete the node inside of the linked list. So this one's pretty easy if you think about it. They give you a pointer to the head. You just start at the head. You keep track of the last that you saw. So ahead, you don't keep track of anything. So let's say you start at 5. And you know you can start at the second node because it tells you will have at least 2 elements. Okay, so you know you can start the second node. So you start at head plus 1 and you make the previous or the last scene equal to 4. And then you just say, okay, at the current one that I'm at, is it equal to the node that I want? And in this case, it actually just happens to be true. You do want to delete 5. So then, okay, I know how my previous, I know how to get my next, which in this case may be null. However, they told you that you're not going to be given the tail to delete, so this next won't be null. But it doesn't really matter if it was null. You could always just, the algorithm would actually be the same exact thing. You would want to make the previous's next equal to whatever the 5's next, what the current's next is. And that's simply how you delete the current node. So let me just do this real quick. So like I said, prev is equal to current node, and then cur is equal to node.next. So that's the thing. Also in Leetcode, they're going to give you this predefined class that you can just use for a linked list. However, in an interview, you're going to need to be able to come up with this little snippet really quickly. So just keep that in mind. You might choke in an interview and be like, oh my god, I studied for everything except for I forgot how to define a class in Python, because you never had to define your own class when you're doing Leetcode, right? So just keep that in mind. Go over going through an actual question on a whiteboard where you have to write every single little piece of code by yourself. Just go over that, because you definitely don't want that to be what you're thinking about when it comes to a harder algorithm question than this. So I'm trying to figure out where they're passing in the actual, what do you call it, node that you want to find. It says node is equal to 1, so this might actually be an integer. See, this is why I actually don't like Python sometimes. You can't tell what type this is. And self is this, but this is its own class called solution. It's not part of the list node class. And list node class doesn't have anything called head. Did I delete something by accident? Let me see. Let me keep this. Refresh. Nope, it's the same for the others. Return type node, list node. Yeah, so node is a list node. Oh, it says given only access to this node. Oh, so this is a node within the linked list. So in order to delete this node, though, I need to know what the previous node is. So that's interesting. That's an interesting problem. How do you do that? How do you connect the previous node to the next node of this node? So in order to do this, though, if you don't have access to the previous node, you have no other option but to do. You're basically dealing with an array at this point. You have to shift everything over by 1, and then just delete the last node. Okay. All right. So in this case, still we have previous is equal to 4, current is equal to 5. And what we're going to say is, okay, assuming that the node that they passed in is the one we want to delete, so they're going to give me a reference to 5. They're not going to give me a reference to 4, they're going to give me a reference to 5. So what I need to do in this case is actually figure out how to basically, starting from here, previous is going to equal to 5, current is going to be equal to 1. I want everything inside of here, you put in here, then move on. Everything inside of here, put it in here, then move on. Once I finally reach the end, just delete the current node. Or set it equal to null, whatever. Said that the input would be, where is it? The linked list will always have at least 2 elements, but they might give me the first element, or they might give me the, well, they can't give me the second element because that would be the tail in that case. So yeah, I don't have to worry about that. All right. So at the very end, current will equal none, but the previous one, the last two will be a copy of themselves. So I'm just going to set previous well, I kind of want to keep track of previous as previous because, for example, at the very end, these two are going to equal to, let's say I want to delete 5. This is going to be 1, this is going to be 9, and this is still going to be 9 right here. Right? Yeah. I want this to be null after 1, right? So what I can do here is I kept track of not only, okay, so what I have to do here is, okay, if I know that the current next, so in this case current is going to be 9, current's next is equal to null, then instead I want to do previous next I want to set that equal to none. Else I want to do this whole copying thing. Time limit exceeded. Oh. Oh, I want current. So I guess I don't need this because previous is next. What does this give me? That should give me 4, 1. What? So it puts 1 into 5. Previous dot value is equal to current dot value. Current is equal to current next. increment value. Let's put into previous as value. Previous is here. Previous starts at node. So previous dot value is equal to current dot value. Then increase current to 9. Oh, I never increased previous. So what I was saying is, yeah, I should have 4199 because I never set the next of this equal to this null. At this point, though, I could do the that was a little trick there. Didn't do well in terms of runtime. I only beat 44% of people. I don't know where I am on this picture. I can't really see it. But anyway, this kind of just shows that like it's a lot easier to do problems when you're thinking in your head uninterrupted. It's a lot harder to do problems when you're speaking at the same time, which is what you're gonna have to do in an interview. So if you're not good at public speaking, definitely practice interviewing Leetcode questions while you're speaking at the same time, because it's very hard to focus on coming up with the algorithm, thinking about what they're thinking about you at the same time, and thinking about how you're going to explain it to them so that they understand you. Like doing all these things at the same time is very hard, and it's very easy to solve the problem once you like sit down and think about it. But one thing they're going to test you on is how well you can communicate. And right there, I just showed that I wasn't very good at communicating that. I was able to solve it very quickly using, by focusing on it, but it's not something that you want to practice doing. So I only did that just because it was bugging me. Yeah, let's see. Let's go to problems. To sum, add two numbers. the medium longest substring. I wanted to go back to the. Yes, they were right here this whole time. Trees, sorting and searching, dynamic programming. Here's what we did trees. So give it a binary tree, find its maximum depth. All right, so maximum depth refers to how many layers there are. So in this case, you would have depth 1 starts to here, depth 2, and then depth 3. The maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. A leaf node is a node with no children. So in this case, that's pretty simple. So this is obviously a case of you could do breadth first search, you could do depth first search if you want to. I'm just going to do breadth first search because an interviewer is probably going to ask you why you would choose one or the other. The only reason I would choose depth first search, even though they have basically the same time complexity, is just because I find it easier to code. So create a stack. Well, depth first search is actually, I think, a queue, right? Whenever you, yeah. I guess I'm doing depth first search. Screw it. So yeah, I'm going to set the current equal to the stack's top. I forget in Python. Are they implementing it themselves? Okay, so they have pop and they have append. Now you want to push the children onto the stack, so oh, sorry, was it push or append? I keep forgetting. It's append. So basically what we're doing here is we're creating a stack, initializing it to roots. Then while the stack's size is greater than 0, we're going to be adding more to the stack later on, as seen right here. We pop from the top of the stack, add its children to the current stack. Now, what this will do is actually a depth first search, so it'll start at 3, then we'll push 9 and then 20 onto the stack, and then from 9 and 20 we're going to push 15 and 7. So yeah, that's depth first search. But in order to keep track of what level you're actually on, you either need to tag every single node, you need to do it recursively, or that's when breadth first search goes in. So instead of a stack, that's why I wanted to use a breadth first search. How do you remove the first element? Let's see. Geek for Geeks is actually not that bad sometimes. Pop 0, that's what it is. See, in C++, you don't have, well, at least I don't know any, I don't memorize anything called pop 0 or anything like this, so that's why I like to use Python. So this is not just by changing the stack into a queue, I've turned this entire thing into breadth first search. So now it's going to be 3. I'm going to push the 9 and the 20. I'm going to get the 9. I'm going to push its children on, but then before I get to its children, I'm going to get to the 20. All right, and then that'll do for that. So I still have the problem of what level am I on. So one thing I could do is say, okay, I know that the left and the right of this problem are going to be 9 and 20. So I know 9 and 20 are the edges. So I know that once I've seen 20, I'm starting a new stack or a new, what do you call it, level, right? So of course, when you append the root, you're always at level 1. So what happens if it's, for example, a null? You're going to have to keep track of all of that. And that's definitely doable iteratively, but for the sake of this problem, I'm being lazy. I just want to do it recursively now at this point, just because at this point I just want to get it done with. So and for this I'm going to return a value. So for each node, I'll call recurse. So at each level, for example, I'm going to start at level right here. I'm going to call recurse on the left, recurse on the right. So left and the right, and then up to its root, up to its parent, which in this case it's not going to have any parent, but up to its parent, I'm going to return the maximum of whatever the left and the right return. So in this case, we're going to go to left, for example, okay? So what is recurse of left? Well, we're going to get to left, and we're going to say, okay, let's just call level plus 1. So we're going to be at 2 here. And then I'm going to call recursion left and right, which in this case are both null. So they're just going to return 2 as well. And then 9 is going to take the max of this, which is 2, and return it to 3, or to this parent node. And 3 is going to get 2 from this side. Okay, but now 3 is also going to look at the right side. When 3 looks at the right side by calling cur.right level, you're going to get 2 here at 20. And then 20 is going to add 1, and then it's going to put it inside of this, and then it's going to say, okay, now we're at 2, call left and right. Calling left and right both return 3. So 20 returns 3 to 3. And now 3 is looking at 2 versus 3. Well, 3 is just going to return 3. This is just a Python thing when it comes to like classes. Recurse, excuse me. Recurse is not defined. Oh, right here, right? At line 16. Yeah, that's definitely it. Is it? See, this is the details you don't want to mess with during the interview. I actually think I messed that up. Line 13, yeah. That's gotta be it. Cool. Now, the only problem is I'm getting 4. Why am I getting 4? Let's see here. Oh, because I'm starting at the root, but it should be starting. So yeah, that looks right. Cool. Bad runtime. Don't know about the memory. So let's see what people with good runtimes are doing. Oh, they just didn't call another function first. But they did basically the same thing I did anyway. Oh, they just returned it +1. You don't need to keep a variable. I see. You just return the max to the left, max to the right, and then +1. That's obvious. Okay. So that's why I did it wrong there. I could have made it faster if I had done that. An interviewer might ask you that. I'm not sure. But yeah, that's fine. I think it's fine. How do you get to the... Is it Explorer? Is that what I did? Top interview questions. Easy. Cool. Link list. Let's see. I've been streaming for over an hour now. I think that's good for today. So those are some warm-ups. I haven't done Leetcode in a bit. I already got my job offers, so you know that just shows, like, you know, obviously I was very rusty and I haven't done Leetcode in a long time, so that really showed. And I think that just shows you that even if you think you're really good at it, definitely try to get some warm-ups, especially right before the interview. As I remember when I did an onsite like a month or two ago, I did an onsite, and right before it, I just did a very quick, warm up question, got my mind into it. It gets easier as it goes. All right. Hope you guys learned something. I hope this inspired you to do some more practice for the interview.